Okay, so today our speaker is Ian Brunges from SCOOS. Ian was one of our fellows this summer, and let me grab the title of your talk. Oh, it's right there. He's going to talk to us about automating a publishing workflow for continuous data using GitHub Actions. Um, let's see, I think everyone is already muted. There's a few little bits of administration. We'll let Ian talk, and then we have a fair amount of time for discussion. And um, I think go keep yourself muted for just listening. And Ian, I'm going to turn it over to you now.
Great. Thank you, Margaret. And thanks everyone else for signing in. So yeah, as Margaret mentioned, I was a fellow with EDI's fellowship program this past summer, where I got to work with the Southern California Coastal Ocean Observing System team, the SCOOS team, out of Scripps Institution of Oceanography. And one of the things I was able to work on with the SCOOS team was automating a publishing workflow for continuous data using GitHub Actions. So for just a little bit of additional context on the project that I was working on with the SCOOS team, it's called the California Harmful Algal Bloom Monitoring and Alert Program, or CalHAB-MAP, which doesn't even really help to make it that much shorter. But essentially, it's a statewide initiative for collecting oceanographic data that is of interest in supporting predictive models for kind of assessing the when and where of harmful algal blooms. So harmful algal blooms, if you're not super familiar, are as described. They're harmful. They tend to sort of introduce a lot of toxicity into water. They result in a lot of marine strandings. They can kind of shut down waterways and shut down sort of tourism and sort of the economic drivers that are dependent on ocean systems. And so they're bad. So California has kind of put together this initiative that's sustained through the IUS regional network, the Integrated Ocean Observing System Network. So specifically Southern California and then Central and Northern California. And they sort of oversee this collection and curation of HABs data, we're calling it, harmful algal bloom data. And so on the right, we can see, some of the things that we're looking for in the water samples, Cedonesia, Ceratium, and a lot more, actually. There's quite a few sort of variables that are measured in the water samples that are being taken. And we can see on the left here that there are 9 different sites along the California coast where the sampling and analysis is taking place. So each one of these sites is operated sort of independently of one another. They kind of all live under the umbrella of SCOOS or CENCOOS, but the actual PIs that are out there doing the sampling and the analysis are kind of independent of one another. And in some ways, that kind of presents a potential challenge because sort of the time frame and even the methods can vary a little bit in the sampling and the analysis. But one of the great advantages of the project for me when I came in is that the previous data manager with the SCOOS team already set up a pipeline to ingest the data from each of the 9 sites into a standardized format and placed it all onto an ERDDAP server, which if people aren't familiar with is like I think it's like a NOAA provisioned server for tabular data. And here are some of the other measurements that are taken. It's not just species, but those are definitely kind of one of the primary things that the HABs team looks at. but also, sea surface temperature, chlorophyll, things like that. And so the overall objective that I had coming into this was to automate a workflow to publish the data that lives in ERDDAP and publish it into data repositories like EDI and GBIF. The motivation behind this is just to kind of increase the accessibility and the visibility of this data. ERDDAP is it kind of has a weird interface. It's not super intuitive. It's much nicer to be able to look at sort of a fully described data package that's hosted, on EDI or GBIF or OBIS. And so I guess the team found through kind of an initial publishing of the data last year that once they had it out on one of these external repositories outside of ERDDAP, just the visibility of it went way up, and they're hoping to put this data out there for the community who might be able to benefit from it. But the workflow itself is kind of broken down into two primary components. The first being to build the data package from the data that's living in ERDDAP, and then to take that data package and then publish it to EDI or GBIF. Currently, the workflow is only implemented to publish into EDI, where Margaret and I actually are both kind of similarly aligned that we'd like to figure out programmatic publishing into GBIF, but we're not quite there yet. So anyway, I want to sort of step through each stage of this workflow, starting with the first part of building the data package, which is just to pull the HABs data from the ERDDAP server. So like I said, definitely potential challenges in having 9 different sites with different researchers collecting the data in different ways and uploading it at different times. Fortunately, I didn't have to wrangle with any of that. I think that was a large part of the efforts for a lot of the other EDI fellows with the teams that they were working on. But I was very fortunate to be able to come in and have all of the data looking identical and all living in the same exact place. Also, I will just note that our two kind of main components here, building the data package and then publishing the data package, these are basically representative of R scripts that I ended up writing. So this is the first part of our building the data package script. And we're using an R library called ERDDAP just to interface with the SCOOS ERDDAP server and pull that data down, which is definitely an easier step than I think many would have in sort of just getting collected, standardized, data. The second part is actually building the data package that we can submit to EDI or GBIF. For GBIF specifically, one of the prerequisites is transforming the data into Darwin Core Archive format. So if anyone is not familiar, just a kind of quick brief on the Darwin Core standard. Darwin Core standard provides like a standard and reliable framework for biodiversity data, for kind of representing and compiling biodiversity data. Essentially, it is defining like a standardized set of terms that can be represented in the data files, and then also dictates which data files specifically need to be present and what attributes those data files need to contain. There's a couple of kind of variations within the Darwin Core Archive format. For this data set, we're using what's called Event Core. And really the important takeaway here is that our data package needs to be formatted to have these 4 files: event, occurrence, extended measurement or fact, and a meta.xml file. And that meta.xml file is different from an EML metadata XML file. And we'll see that in a little bit. But so to actually do this transformation of the data, which is coming out of ERDDAP and is definitely not in Darwin Core Archive format, is mostly an exercise in just understanding how the data maps into the Darwin Core compliant equivalents. And again, I was really fortunate that I was able to come in and that work was pretty much already done. So the previous data manager in tandem with Abby Benson from USGS, they sort of worked through what that sort of transformation needed to look like, and already had a script for me to build off of, which was really nice. But essentially, we're using a few different R libraries to do this transformation. And what we end up with is that set of files, event, occurrence, extended measurement of fact, and meta, that is inclusive of each of the sites that we've ingested from ERDDAP. So the data package that we're trying to publish is inclusive of all the sites, and it's not site specific. So after we've done this transformation and we've kind of generated the data tables for our Darwin Core format, we can write them out to files, and then we have them sort of ready to be kind of included in the data package. The third part of building our data package is constructing an EML document, EML metadata document that's describing the data package. So for this, I have a few sort of different approaches that I'm using in tandem to ultimately put together a comprehensive metadata document. The first thing that I'm doing is I'm actually just starting with like a template XML, that contains some of the more static properties. So things like how the data tables are structured, the attributes they contain, annotations, things like that, where unless I was making explicit changes in my script, sort of during the transformation step, these aren't going to be changing. So in reading in this kind of base template, it gives us a good sort of object to build off of from there. So the next approach that I have is I wanted certain fields of the EML to kind of remain easily configurable by the SCUS team, So for example, the title, if they decide, in a couple months from now, oh, actually, we don't like the way the title is worded, we want to go change it, rather than have them having to go in and either, update code or, actually get into the EML, XML document itself and try to make changes there. I created a few CSV files that contains these properties that they can just go in and edit. And those changes will get propagated into the EML when the script is run. And actually, I will show just a quick example of that. So here is one of the CSV files for geographic coverage, for example. So maybe maybe next year they've added a new site in the very upper part of California, and they need to change the north bounding coordinate. They can just come in here, edit the CSV. It's very straightforward. And the next time that the script is executed, that change will get propagated into the EML document, and it will properly reflect whatever changes they were hoping to make. So I have, sort of config files for geographic coverage, keywords, personnel, and title and abstract. And then the third approach here in creating EML is to actually programmatically generate EML for some of the more dynamic fields by essentially, scanning the content of our data. So something like temporal coverage can be inferred by looking at, what is the first date that exists in my data? What is the most recent date that exists in my data? And we can set the temporal coverage based on that. generating the physicals for each of the data tables is also another thing that's done programmatically, where after we've built the files in the previous step, we can then look at them and say, how big is this file, and assign the physicals, which is one of the attributes of EML. So once all that's kind of done, then we have written the email out to file, and we have essentially constructed our full data package. It's kind of ready to go, just about. And so we'll kind of skip ahead a little bit here to our script for publishing the data package. So as I mentioned, right now, we have a script that is implemented to publish to EDI. And this is relatively straightforward because we were able to use the EDI utils R library to essentially just query the EDI backend to do this update. And the EDI utils API made it really easy to interact with. And there's sort of 2 points where we're communicating with it. The first is to query for the current version of the data package that lives on EDI that's currently published. So right now, I think that is EDI.988.3. And when we're updating it, we need to update the version number on here. So we're basically just grabbing that version 3, incrementing it. Now we have version 4, and then that's what we're sending in with our update request. And that update request is done with API update data package function from the EDI utils library. And with that, we're essentially just feeding it the EML document that we gave, which contains pointers to where the data files can be accessed. And that said, there are a couple of missing components here. You'll notice kind of first and foremost, I skipped over the step to stage the generated files for publishing. So the EDI backend essentially requires in the EML that for each of the files that you have represented in your EML, that there is some web accessible download link essentially that it can point to and say, okay, this data table is coming from the file located at this link. And so it became a challenge to figure out, all right, I've generated the data files, but where can I put them so that when I send this update request, it can actually look at these new updated files. So that was one of the challenges. Another was that the publishing step to actually use those EDI util functions requires authentication secrets that you don't necessarily want floating around just in an R script. So that was another challenge that needed to be addressed. And then the final challenge, and in some ways kind of like the biggest one, was, all right, we have this workflow, we kind of have each of the steps to generate our package and to publish it, but how do we automate this? How do we make it run so that, I don't have to touch it, I can just say run on the 1st of every month or whatever, or every other Friday or something like that. And it turns out that the solution to kind of all of those was GitHub Actions, which was kind of a fun discovery. I had tried implementing this whole workflow a couple of different ways. I played around with Docker. I played around with like Jupyter notebooks in a proprietary virtual environment. And they kind of each fell short at some point along the way here. But GitHub Actions ended up being able to kind of provide actually a really nice solution to all of the challenges that we had. So just a quick overview of GitHub Actions. So we're using GitHub Actions specifically for the R language, although it supports many. But it's a relatively new service that's provided by GitHub now that allows you to like run and schedule jobs in a virtual environment. And it supports all of the operating systems. It has pretty generous resource allocation compared to similar services. I think it's something like it allows you to be running 20 concurrent jobs that take up to like 6 hours each. There's really minimal setup outside of just kind of the usual provisioning of a GitHub repo and GitHub account, which probably most of us are familiar with. It's free to use for open source academic and educational repositories, which is huge. That's a really big one. Free to use is, yeah, definitely a good quality there. And there's a lot of support, even for the R language, for some common actions like setting up R in this virtual environment where you're going to be running these scripts, or installing package dependencies, things like that. There's a whole kind of list. Actually, I'll take a quick look here. But there's a whole list of example actions that are already kind of like pre-built and verified by the GitHub Actions team. I guess there's sort of an R contingency of the GitHub Actions team that have built up all of these actions. And you can kind of just pull them into your script as needed, or your workflow as needed. There's also really good logging and sort of debugging tools, as I found out. And so some of the common uses for GitHub Actions, I think probably the most common is going to be CI, continuous integration, or testing. I think one of the more common tools used for that right now is Travis CI. So GitHub Actions essentially can provide a replacement to something like that, where somebody on the team has merged a pull request. We want to run the full suite of tests to make sure nothing's broken. All of that kind of stuff can be accomplished in GitHub Actions. There's also other cool things you can do, obviously, like what I implemented, or our markdown workflows for rendering, Shiny app deployment, things like that. And again, there's kind of a whole list of interesting examples here, and example workflows to build off of. So for my use case, the first step was to actually set up our GitHub repository to communicate with the GitHub Actions service. There were a couple of steps involved, but the main one actually maybe is number 2 here. I probably should have put this one first, but essentially you need to create a .yaml file under this folder structure, .github/workflows. And once you have that YAML file there, GitHub automatically kind of includes your repository in its screening of the GitHub Actions services, which is really cool. That YAML file that you create there is also going to be where sort of the bulk of your steps of the workflow go. And we'll get to that in a minute. Another step that I took, and actually I have just recently kind of been testing as to whether or not this is necessary, but is to, with your R project, actually create a package out of it. There's a nice library called Use This that makes it really straightforward to do this. Basically, it turns your R project into an R package, essentially. And what this allows is the creation of a description file, which some of those pre-built actions that I was just showing you can reference later on, and it just makes some of the configuration easier. Like I said, it might not be 100% necessary. I'm still kind of testing that out. But and then third, for your GitHub repositories, you need to set up an environment, which is something that you can do pretty easily, in the GitHub UI. But that environment is will encompass the run of your workflow and can hold, the authentication secrets or whatever else you need there. So I'm going to step through the YAML file that I built. but essentially, it's sort of just dictating each step that we need to take in order to run our scripts. I have it open somewhere. Okay. All right. So the first line here is dictating the trigger for this our GitHub action, for our action essentially. And right now, you can see this is commented out, but basically on a schedule is when I want this to run. This is commented out because I've been doing some testing. So on workflow, dispatch is a really kind of helpful thing that you can set that allows you to go in and actually just manually trigger. So like say I've made a change down here, I want to test that change. On workflow dispatch allows me to just go manually trigger it, see what happens. But the regular state of this file will be using the schedule here, which uses cron scheduling to kind of assign a runtime for this. And GitHub Actions, the GitHub Actions service will be able to kind of read this and understand, hey, this is when we want this to run, and it will run it for you. So it just uses the cron syntax, which essentially is like, it's like minute, hour, day of the month or something. And then essentially what this is saying is we would want this to run on the 1st of every month at midnight. So which is just kind of the cadence that we decided on at the Scoos team. Like I said, if we wanted to make it run every week or something, we could change that. It's all configurable here. So that's the first step there. The second chunk here is actually defining the job that we want to run. And so we've built this job called generate data. We're referencing the environment that I mentioned we had to build inside of our GitHub repository. Mine is called HABs publish. And then we're setting up kind of the configuration of what operating system do we want this to run on, what dependencies does it need, and all of that. So this whole chunk, basically from here down, is actually stepping through what we need to accomplish. So the first one, this is a pre-built action from GitHub Actions. It's actually just checking out our repository. So let's see. So this is the repository that I've set up. So step one of this is actually to check out that repository. Then we're installing OS dependencies. We're using a pre-built action to install R and get R all set up in kind of this virtual environment. And then we're installing any R dependencies that we need. So all of the packages that our script is dependent on. We can see, EDI utils here. That's one of them that we need. And then we're installing all the dependencies. So pretty much this whole chunk up to here is just kind of setting up the virtual environment, which is, it's running on Linux, and it's just essentially spinning up R so that we can run our scripts. Once that's all done, we can actually execute the R scripts that we wrote. So this step here, generate our Darwin Core Archive data package. This is kind of that first chunk that I mentioned, where for building the data package, and it's just running this script. So source on that script file, it's just executing that script. And if you recall, the results of that script are files being written out to a specific folder. Then kind of comes the point here where we can stage the generated files for publishing. So that's not something that we accomplished in either of the R scripts, but it's something that GitHub Actions allows us to do. So after we've generated these updated files, we've written them out into our repository, which we essentially have checked out. we can then commit those files back into the repository. And what that allows us to do is it allows us to kind of keep in a singular place the most up-to-date version of these files, so that during the publishing step, it can always look back to the same place and see and always get the most updated version. And so this is actually making a commit into your repository. So it's taking, all the files that we changed, updating them, and then committing them in. And I've been making a lot of commits here, but we can see here, here's an example of that commit happening. So updated auto-generated dataset files. The commit was made by Actions user. So you can see that's all happening, through the execution of this GitHub action. Once we've committed the files, then we can move on to our publishing step, where we are ingesting our authentication secrets, and then running our publishing step, which can then, use these secrets that we've passed in and execute the publishing. And then after that, we're just kind of closing out the session, just sort of printing some session info, and that's the entirety of it. So unfortunately, I decided this morning that I wanted to try to make some optimizations to this YAML file, and I think I broke some things. Okay, this one worked, so that's good. But you can see, so this is just a tab under the GitHub repository. So this is my repository. There's an Actions tab here. And I can find the workflow that I've created with that YAML file. And like I mentioned, right now, that workflow is set to run on a manual trigger. And we can see that here. If I wanted to, I could run this workflow. So that said, this was one, I guess I was testing half an hour ago. And I can see each step sort of that I've established in that YAML file. So here's kind of the setup, installing the environment, and then here's where I run that first script, and it's got, it gives me all the output for that. Here's where this is where I commit the generated files, and then here's where I publish to EDI. And I can, I already know that it didn't fail, which is good, but I can always look back here if something went wrong, maybe in the publishing step. I can come back here and check, all right, what were the errors? Maybe what went wrong here. And yeah, and so that's kind of the whole thing. Like I said, I'm hoping to extend the workflow to include a step to publish to GBIF. And the whole workflow is created such that I can essentially, if I can write a script that is appropriately interacting with the GBIF registry API, I can just add that script just like I had the publishing to EDI script in there, just as an additional step in my publishing workflow to run automatically. Alternatively, I could create a new workflow entirely, a new YAML file or a new job within that YAML file. Like maybe I want the update to GBIF to happen at some different cadence. I could create just a different job that essentially mirrors what I've done already. So that work is still kind of experimental. It's still kind of underway, but that's the next step for this project. So yeah, thank you for listening, and let me know if you have any questions.
That's really cool. Thank you, Ian. I think we're still recording. I'm going to switch it back to gallery so I can see people's hands. I actually have 2 questions. Can I ask a couple questions?
Yeah, of course.
Anybody
Please.
else can. So some people who've put data into into GitHub using data, to supply the URLs and whatnot, or for whatever reason, run into file size limits. Do those still apply when you use the actions?
Yes, there are file size limits, definitely. So I can show you here. So basically, this is something that I had to assess, and kind of came to the conclusion that at the rate of growth of the files that I'll be publishing, we wouldn't run into that for 100 years, which is maybe not the most eloquent way to go about it. But yeah, the GitHub file size limit could be an issue for very large files. So you can see this is the folder. This is my data package folder where my auto-generated files are being updated. And so we can see, this link here is essentially the link that we're passing in our EML as the pointer to, hey, this is where you can find this file. And because I'm committing those files always into the same folder, this link, this like sort of download link essentially is never going to change. It's always going to be the same, which is really nice. But yeah, eventually, if the file became too large for GitHub to want to host it, then we'd have to find another solution.
And so my other question has to do with managing it. So if since you're basically a temporary employee, I mean, you're not working, you're not going to stay with SCOOS, you just have someone else fork this repository, or you change its ownership, or how does the management going to work?
Yeah, so what I ended up doing is I ended up creating this repository under SCOOS's own GitHub account. So essentially, like I kind of prototyped this all on my own, and then towards the end, just sort of reached out and was like, it's not appropriate for me to own this repository, and so I kind of just re-provisioned it under SCOOS's own GitHub account. They have since kind of transferred their GitHub account from being like an individual account to an organizational account, which allows you to kind of pull in different GitHub users and assign different permissions for them to touch different repositories within it. So at this point, the repository lives under SCOOS's own GitHub account, but I have access to come in and make commits to this if I need to. That said, so does the SCOOS team has been working with a company called Axiom for a lot of their kind of data management solutions. So Axiom was kind of the main group that I needed to keep in mind when handing this off to. But they're able to come in and make commits all of the same. They needed to, make changes, and otherwise, I hopefully did a good enough job describing, how everything is working and all of that, so that they could maintain it moving forward.
Okay, so it's going to be Axiom who takes this over, it sounds like.
Axiom, I think, will take this over, yeah.
Okay. Well, who else has questions? Those were mine.
There might be a couple in chat here.
Stace. Yeah, do you want to just ask Stace, or should I read this?
I think my microphone might be connected. Can you hear me?
Yeah, okay, I hear you.
Yep.
Okay, I don't have a camera on this computer. Hi, Ian. Really great job. I'm just really impressed, and I think your work will be very relevant to other LTER information managers as well. So we'll be sure to share this with them. And my question is with regard to an upstream part of your workflow, and it's in terms of populating the Darwin Core Archive. You mentioned ERDDAP as your main source, and I'm wondering if you needed additional sources in order to provide all the required content for GBIF and OBIS. And that means, like, basically, did you need to pull in anything like a taxonomic identifier from an outside database in the
yeah. Yeah, that's a great question. Yes, I think the majority of what we needed to populate our Darwin Core Archive package did come from ERDDAP, with the exception of some of the taxonomic coverage. So I mentioned when we're creating the EML document, taxonomic coverage is one of those things that we are programmatically generating and adding into the EML document. So that's using an R library called Taxonomy Cleaner. That is essentially given or fed a list of all of the taxonomies that might be present after kind of scanning through. But doing that initial scan of what taxonomies are present in this data is where we kind of first need to source some additional data from an outside database, I guess. So yeah, there's a database of taxonomies, and I'm trying to recall exactly which we use, but where we're pulling out kind of the standardized like identifiers for each of these taxonomies, and that way when we're then querying for to populate the EML and also to populate some of the fields inside of the data, the Darwin Core Archive data itself, we have kind of the standardized identifiers for the taxon. I'm trying to recall, like I said, what database we're using. That was part of the script that Vicky and Abby kind of had originally worked on, and it's not something that I created myself.
I would guess that you're using worms. That's what Obis wants you to use.
Yeah. Yep. So we do have the worms library here, the R package worms, and so yeah, I imagine we're querying from there. Okay. Yep. Yeah. So yeah, we're using worms to do a taxon lookup. Yeah. Otherwise, I think that was the only bit where we needed to query some external source of information. Yep.
So that means that everything, and this is just that their upstream data collection is pretty comprehensive, that everything else was in ERDDAP somewhere. Sampling sites, people's addresses, whatever.
Well, so things like that would go into the EML metadata. Like,
oh, that's right. You have an external text file. Yeah.
Yeah. So yeah, for things like that. But so for constructing the data itself, though, essentially all of the data is from ERDDAP. It's just kind of reconfigured to fit under the Darwin Core expected format. Actually, I might have. Yeah. So essentially, this is one of the files. This is the event file, and basically each one of these rows in here is representative of a sampling event. So this was at the Cal Poly Pier on August 15th, 2008. This was August 19th, 2008. So each of these are sampling events. Then we have our occurrence file, which references a sampling event and is essentially saying at this sampling event, these organisms were present or these measurements were found to be taken. And so all of that data on, this organism was measured during this sampling event, with this quantity or with no quantity, that is all in ERDDAP already. So it was just a matter of kind of reconfiguring it. And, here's so like, for example, here is one of the GBIF Obis requirements, the scientific name ID, and I think taxon ID. And so these are what we're pulling out of worms.
Right. What's interesting to see your Darwin Core. So the Darwin Core data is never in, what am I trying to say? It doesn't live in ERDDAP as a Darwin Core file. That's not what's in ERDDAP. It's got the precursor.
Yeah, correct,
Yes.
correct.
Okay.
So I think this is sort of each of the data repositories for each specific site. So in ERDDAP, each site has its own data set. So there's Cal Poly, Monterey Wharf, Newport Pier, and then the data for each of these, I think this one is Cal Poly, but this is what the data looks like in ERDDAP, where, you know, essentially, like I mentioned in my transformation step, we're going from wide to long format. I mean, as part of the transformation, but you know, something like Alexandrium, you know, we have an organism quantity measurement for Alexandrium, you know, at this location on this date. So that becomes an occurrence given like for this event. And then the organism name becomes Alexandrium, and the organism quantity becomes, you know, whatever the value is.
So yeah, that's interesting that you put the unit. In this case, it's the unit that becomes the. Anyway, this is Darwin Core minutia now.
Yeah, yeah.
We don't have to talk about that.
Yeah, yeah, and there is a lot of minutia there, and you know, like I said, that effort was largely tackled by
done already
by Abby and Vicky,
Yeah.
the previous data manager, which definitely helped to kind of expedite my workflow. But yeah.
So I have another question. EDI, if the original data set is already in EDI, for instance, this data set that's in ERDDAP, there is a workflow system built into Pasta that could generate a downstream data set. Did you look at that at all? But since in a way I can see that it's not really a choice, since you wanted to come straight out of ERDDAP, not necessarily make that step to archive a second data set. But I'm just wondering if.
No, actually, it's something that I think towards the end of my fellowship I kind of learned about, but I think would actually be interesting to dive into a little bit more. Maybe at some point, Margaret, it would be worth going over what that involves and what we can accomplish with that. Just to see, because yeah, there might be some redundancy in what I've implemented with some of that functionality that already exists.
Well, that also needs to have a data set that's the original data set that would be housed in EDI or in EDI as well. So that would mean instead of coming out of ERDDAP, it would come out of an EML described data package in EDI. Right. Run a script, create another one. Right. That's the kind of workflow we're using for the Darwin Core archives that we're creating. So that was why I was curious.
Okay. Yeah. All right. Question in chat. No, actually, so I have not shared a link or any links yet. Margaret, should I put these just in the chat here? I can share a few of these. I'll share the repository itself, and then I'll share maybe some of these GitHub Action resources.
Well, I think we'll post a recording of the talk and the discussion, and some things people will be able to figure out, like if they can find the SCOOS org in GitHub, they'll find this repository.
Yeah.
Is that right? So there's that as well. Okay. Did Suzanne ask you, excuse me, would you give us a copy of your slides? I'm not sure if she.
Yeah, I definitely can do that.
Okay. Yep. Because then people could probably see it there as well.
Okay. And then, yeah, like I said, I'm also just putting some of these into chat now, just in case anyone wants to pull them up now.
Oh, okay, great. I'll stop doing that.
And then, great.
Colin, looks like Colin has a question.
Yeah. Hi, Ian. Great talk today. Really cool stuff. Thank you.
Yeah, thank you.
A question about triggering the workflow. So in the EDI data repository, we have these things called event notifications. It's a process. When you can subscribe to a data package in the repository, and every time it updates, it sends out a notification to an endpoint that receives a post request and a MIME type of plain text. And in that payload is essentially the identifier of the data package that was updated.
Okay.
Are you aware of a mechanism by which your workflow in GitHub Actions could be triggered by such a payload?
That's a good question. I'm not sure. So I'm not sure what is like the receiving end of that payload typically.
It is typically a web server that's listening for a post request.
Yeah. I'm not sure if GitHub Actions currently has that type of trigger. Although that being said, I haven't, explored too much of the different types. I think I don't know. We'd probably have to look into it a little bit more. The main ones that I know of are scheduled, the manual like workflow trigger, or pending some like pull or push or some action on the GitHub repository itself, since it's all kind of isolated there and it knows to listen to that. So yeah, I'm not sure.
Okay, yeah, great. Yeah, I wonder if there's some sort of a workaround if it can't accept it directly, if there's a scheduled task that could be listening nightly that's relatively lightweight. And then I don't know if that's possible to create a pull request from one repository to another to trigger. Anyway,
yeah.
Thanks for entertaining the question.
Yeah, sure thing. Yeah, I mean that's one of the really, I think, exciting things that I found when working on this project was that GitHub Actions was a totally new tool for me. So just kind of like getting a little sort of brief on the different things that you can achieve with it and what it can do. It's kind of exciting. It definitely seems like a powerful tool. So.
Awesome. And one quick comment about the file size limitation that one can encounter in GitHub is that we recently implemented support for box storage to be able for a user to be able to stage data in box.
Oh, okay.
And then EDI, the pasta backend is able to then upload from box is a lot, but I mean, there's some requirements. I think it needs to be a stable URL with no redirects, which I think may only be offered for the premium user. But that's kind of the main issue that we encountered when, from the repository side, trying to upload from a stage data package, maybe in Dropbox or Google Drive or whatever. You get all these redirects that are hard to follow, and so we're working on solutions to that, and we have recently released one that works for Box. So
yeah, that's great.
Just an FYI.
Yeah, no, that's good to know, because that was one of the first sort of challenges with my workflow that I encountered, was like, where can I actually put these files so that the pasta backend is able to reference them and look at them. And I think I was having a conversation with Matt Biddle, who some of you may know, and he suggested, GitHub as a way to host them. And so, yeah, for my use case, that definitely worked out. But yeah, I think for something like Box, it would be fairly straightforward. Instead of committing your generated files, back into a GitHub repository, you're just interfacing with, Box API to get them into there. So.
Yeah.
So Ian, what other place to have put them would be just back into ERDDAP?
ERDDAP isn't, so I don't know. ERDDAP, I think, like specifically is a means to host like tabular data. It's more of like a database with kind of a clunky UI on top of it that lets you essentially like send queries to it, like select these fields from, when, blah, 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 whatever. And it's not so much of an actual like server for hosting files.
Okay. So read the entire table might not have been something as straightforward with it as a, okay. Okay.
Yeah.
Yeah, really cool, creative solution to these problems that you were encountering. Thanks again for the talk.
Yeah, thank you. Yeah, and just kind of a shout out to everybody at the EDI team, Colin included, just helping me kind of work through all of the nuances of interfacing with EDI, using the libraries, and just helping me debug some stuff. EDI team was really great, helping me out all the way through. So big thank you to all of you guys, and just for the opportunity to come out and talk today and do my fellowship over the summer. So thank you.
Yeah, and thank you. So Ian actually is at UCSB, well, not physically, virtually, whatever.
Yeah, actually, this week we'll be in class.
Classes start. I know. I'm also at UCSB. This is why I find this interesting.
Yeah.
Someday we'll run into each other because I think we're actually in adjoining buildings.
Oh, really?
But,
yeah. I'll come say hello.
Yeah. One of these days, well, we actually might be on. And so I hope we see Ian again. So, okay, well, it's the top of the hour, so people probably have places to go. I'm going to shut off now, unless there's more questions. Oh, I see. No, that's a hand. That's a applause. Okay. Thanks a lot, Ian.
Wonderful. Thank you, everybody.
Okay. Bye.
Bye-bye.
Stop.